This lesson is over difference of squares. Factoring a difference of squares. Well, notice the word difference. Difference is a fancy word for what? Subtraction. So what that means is we're talking about the subtraction of squares. Well, if we were to look at a squared minus b squared, well, since it's difference of squares, it means we need to know exactly what our squares are. So let's review a list of our squares. 1 squared means 1 times 1, which we know equals 1. 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. 5 squared equals 25. 6 squared equals 36. 7 squared equals 49. 8 squared equals 64. 9 squared is 81. And 10 squared is 100. So these values, these squares, are the numbers we need to be on the lookout for. So since we've identified these squares, how does this pattern work? Well, the a squared means that value has to be a perfect square. It has to be some value that times itself would give you a squared. Now, b squared has to also be a perfect square. And then we must have the minus sign, because remember, this is difference of squares, so that is a requirement. So if you encounter this pattern of perfect square minus perfect square, then we can instantly go to the factored form. The factored form will be 2 sets of parentheses. Because our first term was a squared, we have to identify what value times itself would give you a squared. Well, that would be a, which means that would be your first term in the first parenthesis and the first term in the second parenthesis. Next, because b squared was a perfect square, we need to know what value times itself created b squared. Well, that would be the value of b, which would be the second term in your first set and your second term in your second set. And then the last part is, well, what about the signs? Well, one has to be a minus, the other needs to be a plus. It does not matter which one has which sign, they just need to have different signs. So we've talked about the pattern, now let's look at an example. Example 1 says to factor, and for a we have the problem x squared minus 25. And so we look, is x squared a perfect square? Yes. Is 25 a perfect square? Yes. Notice it's in the list on the right. Do we have a minus sign? Yes. So this does follow the pattern of difference of squares, so we instantly have 2 sets of parentheses. Now, what value times itself gives us x squared? Well, that would be x. And so that would be the first term in both sets of parentheses. Now we look at 25. What number times itself would give you 25? Well, that would be 5. And so that would be the second term in both sets of parentheses. And then the last part, we need different signs. One's a plus, one's a minus. Again, it does not matter which order you put that in, plus then minus or minus then plus. And that would be your answer. Problem B, we have 4y squared minus 9. And so we look, is our first term 4y squared? Is that a perfect square? Which means, can you think of any number that times itself would give you 4y squared? And yes, there is a number. Is 9 a perfect square? Yes. And so now we look at the sign. Do we have a minus sign? Yes. So we can instantly write this in two sets of parentheses. And now we look at our first term. What times itself would give us 4y squared? Well, that would be 2y. What times itself would give you 9? 3. And then what do we know about our signs? They have to be different. So one's a plus, one's a minus. And that is your answer. For C, we have 1 minus m squared. Is 1 a perfect square? Well, notice it is in your list on the right, so it is. Is m squared a perfect square? Yes. Is there a minus sign? Yes. So this instantly factors into two parentheses. What times itself gives you 1? 1. What times itself gives you m squared? That would be m. And then about our signs, one's a plus, one's a minus. And that would be your factored answer. 1 plus m times 1 minus m. For D, we have d squared plus 49. Is d squared a perfect square? Yes. Is 49 a perfect square? Yes, it is also in the list along the right-hand side. Is there a minus sign? No. This is our first time encountering this. This does not follow the pattern of difference of squares. Instead, because it has a plus sign, we call this the sum of squares. Because sum is a fancy word for addition. Now here's a fact about sum of squares. They're not factorable. They cannot factor, they cannot be rewritten. So what do you call a number that cannot be factored? Well, we call that value prime. And since d squared plus 49 cannot factor, we simply say it is prime. For problem E, we have g squared minus 81. This is your try it problem. Hopefully you found the factored form to be g plus 9 times g minus 9. Again, it doesn't matter the order of these sets, you just need to have both of those parenthesis sets. For problem F, we have 9c squared plus 25. This is also your try it problem. Hopefully you noticed this one has a plus sign. This is actually a sum of squares, so the final answer would be prime. It cannot be factored. For problem G, we have 64 minus p squared. This too is a try it problem. Hopefully you found the factored form to be 8 plus p times 8 minus p.